Hey guys, it's Simon and welcome back to the LibGDX Kotlin RPG tutorial series. So we are already quite far in our development because we can already create now physics bodies, we can move around our player, we create collision objects out of tile, for example for the tree and the stone, we can walk through other dynamic entities, we can create either also dynamic entities like the chest, which we later on can interact with. And yeah, so we made quite some progress, and in this part we are going to enhance on the logic with the collision object creation, because as mentioned in the last part, currently we are creating it for the entire map, and the map could be very big, and we don't want that we create useless physics bodies which are not needed. And the approach that I chose for this game to improve on that, not saying that this is the best approach, but it's one way to solve it. And the way I did it is that I give a specific component to entities which should be part of the collision handling logic of our game. So for example, the player and the slime, they get a so-called collision component, which simply flags them that those are components which should create and also despawn collision objects. And then always around such entities, so for example here, around the player in an area of, let's say, 2 by 2 tiles of our map, it will check what kind of those tiles have a collision information, and if it has some, it will create an object. And once the player is out of range of this object, then it will get removed if there are no other entities with a collision component, so no other entity which is interested in collision objects. So that way I dynamically create and also remove collision objects from the map. And this could be further on improved with the spawning of entities itself. So right now we also create the player, makes sense of course, but also enemies like the slime or the chest, for example, we also create them immediately, but we could also make a similar approach and only create such entities when we are close to them, that they are interesting for us. I think this is also how it works, for example, in Super Mario Maker, because I heard a lot of streamers that I watch from time to time that they despawn objects and they respawn objects. So for example, when they move Mario to the left and on the map on the right side there would be a bullet bill or whatever, when they are then going back to the right, then the bullet bill will spawn again and again and again. So there is, I think they have a similar logic there in that game, but most likely optimized because it's Nintendo with smart Japanese people in the background. And you only got me, Simon, which is not the smartest man in the world, but at least I can come up with some solutions. Okay, so first of all, as mentioned, we need to introduce a new component, which is really just a stupid component. Let's call it collision component. And this component is simply there to identify entities which should be part of the collision handling logic of our game. And this component gets added in our entity spawn system. So here, where did we had that? So here it's inside the physics component. Let's add that below here. So if the config body type is not a static body, so it's a dynamic or kinematic body, so a player or a slime in our case, then we add the collision component to those entities. Such entities will create, remove collision objects. Then the next thing is when we go to our CollisionSpawnSystem. Let me hide the console here for you. So in our collision system, last time I mentioned that we will improve on that, and we will not create all these objects when the map get changed. We now create those things dynamically. So first of all, now that we have it available, we can add here the component that was missing. So we only want to iterate over entities which have a collision component, and also we need the physics component information. And now around such entities which have that, as mentioned, we will go through the tiles which are very close to them, and if needed, create then such collision objects. And for that, let's configure it. So let's define a companion object, and there, for example, let's call it, for example, spawn area size, which is, for example, 3 tiles. And now we move our code from here up to the onTick entity. And what do we need for that? So we need, first of all, the different tiled map tile layers over which we want to iterate. So we need to remember them and store them. So let's call that tiled layers. And this is a mutable list of tiled map tile layer. And when the map changes, we simply store that. So from our map, we get them by the type, and our type is tiled map tile layer. And we want to fill our tiled layers collection. Okay, so this is a GdX function, so we need not a mutable list, we need a GdX array. Okay, and let me quickly check. So fill gets cleared internally. Okay, perfect. So now in our tiled layers array, we have the tiled tile layer information, and we can use that here. So here we have our tiled layers, and now use a for each. Then we need to adjust our X and Y position around which we scan if we want to create collision objects. And there we use our entity X and entity Y position, which we get out of the physics components. So that's why all our entities need to have physics components. Okay, so physics components, and from our entity, and there from our body the position. And this is the starting point of our scan. So entity X and entity Y. And those are integers. So let's cast it to integers as well. And here we don't need our map size anymore. Here we need now this spawn area size that we defined below, so that in an area around 3 by 3 tiles, we will check if we want to create such objects. Then all of that is still fine, so we can reuse that. But in addition, which is something that we are going to learn here, we want that now all these entities, so these collision entities that get created, they need to know how many entities are still nearby. And if there are no collision component entities nearby, then the entity will get removed. So the collision object gets removed when there are no other collision entities nearby, because then it is useless to have it there, because no entity is interested or close to it, and the collision can never happen, so we can simply remove it. And for that, we also introduce a new component. Let's call that tiled component, or maybe collision component. Yeah, let's stick to tile component. This is how I called it on the GitHub project. And what we need there, so we need to know to which cell it is linked. We see that in the moment Y. And we also need to have a list of nearby entities. So let's create this component quickly. So we have a tiled component, and this has a cell reference of the tiled map, which we are going to initialize, and it also has a nearby entities set, which is a mutable set of entities. Okay, so coming back here, let's introduce the tiled component. Oh, and of course this add method needs to be inside here. Makes more sense. And here from our tiled component, the cell is equal to the cell over which we iterate, and the nearby entities, there we also add the entity that, which triggered the spawning of that specific cell. Okay, we have here one problem. So if there would be multiple entities close to a cell which has a collision object, then we would create a collision object again and again and again. So somehow we need to remember what kind of cells did we already process. So we need to remember that initially what I wanted to do there is that I set a property on the cell itself, because in one part I mentioned that almost everything in tiled has a property information. So the layer has properties, the map has properties, a tile has properties, but unfortunately a cell does not have properties. So I cannot store arbitrary information on a cell, which is intended most likely and makes sense, but for me it was a little bit unfortunate that it is like that. So that's why I simply store the processed cells so that I don't re-trigger the collision object creation again and again. So let's call this processed cells, and this is again a mutable set of cell. And now very easy in here. So when we go here and we process now this specific cell, we add the cell to it. Okay, so with that piece of code, we are now taking care of object creation, but only around the entity. So we don't spawn them immediately again, we spawn them a little bit delayed. So we can quickly try that out. I think everything should still work. Sorry, it does not properly work actually, because the processed cells currently we don't use that. So this is another check here. So if the cell is in the processed cells, then we also don't do anything because it was already processed. So we don't go to the code here below. So now it is better. Okay, so you see here collision objects are available, but for example here the stone at the top does not have it yet. So if we move our player close to it within that 3x3 tile area, then it gets created. Same here, so now it has spawned, and same here for the tree. So that seems to work quite well, that we are now really creating the collision objects dynamically when we get close to them and not create them all at once. So the next part that is missing is that we also want to remove such cells or bodies, actually collision objects, when they are no longer needed anymore. And for that we are going to introduce another system. Let's call that CollisionDespawnSystem. So this system is iterating over all entities which have a tiled component. So this is that new component that we introduced before and which is only added to these collision objects. So here the code is fairly simple. So we simply need access to our tiled components. And then we just check. So if from our tiled component of that entity, the nearby entities is empty, so there are no nearby entities anymore, then first of all we can remove now the collision entity. So with that we clean up also the box2d stuff. And what is missing now, you might ask, is that we need to update our processed cells here. Because now for that specific cell there was no nearby enemy anymore and we removed the object. But if an entity would get close again to that cell, then we want to recreate it. So we need to remove somehow the cell that we store here below. We need to remove it from that list. One solution would be that this processed cell, for example, is maybe a static set, and then you have access to it from everywhere, or you pass in a reference to the despawn system, from the spawn system to the despawn system, but that is not a good practice because systems should not know about each other. So they should be really independent and not have direct references to it. Making the processed cells a static variable is, in my opinion, also not good, because especially on Android, the life cycle of static attributes is not what you might think. So it could be, if I remember that correctly, it could be that this cell reference is maybe a reference from an old instance where you were running that game, and not the instance of your current game, because the life cycle of such static references is just different. And that could then also cause very strange behaviors. So we want to avoid static references or static variables that mutate in general. So this is also not a good approach when it comes to game development with LibGDX. So what could we do, or what can we do? We can use our event system that we already established. And there we simply create a new event. So let's call that for example, CollisionDespawn event, which takes a cell, because that is the piece of information that we need, and it is a box2d event, a scene2d event. And now when we go back to our despawn system, the only thing that we need is our stage. And with that we can fire an event, which is a CollisionDespawn event. And there we pass in the cell from the tiled component. So we need that again. So let's quickly say with that specific component. So if nearby enemies is empty, then we fire a despawn event with the cell of that component. And now in our CollisionSpawnSystem again, where we are already listening to events, so everything is fitting perfectly together, we can now simply react also on CollisionDespawn events. In that case, we also return true. And what we can do from our processed cells, we remove the cell from the event. And now we have our despawn system, which is quite short and easy, but we did not add it yet to our world. So let's do that. So let's think it through, where we need to place it. Do we need to place it after the spawning or before the spawning? Or does it maybe not even matter? So in the spawn system, we will create a collision entity and already add the nearby entities to it, meaning that in this despawn system, for sure we will not immediately remove the entity again because it has at least one nearby entity. We then do some update, which we did not implement yet, but in a moment we do that in the physics system, so it should be fine. Let's add that after the spawn system. That should be correct. So what we need to do now is to update our nearby entity set of our tiled component, and we do that in the physics system. And here we are going to learn now one way how to react on collision events. There will be another way how we can do that, which I introduced then in the part when we are going to implement the attack system so that entities can attack and deal damage. There we learn a second way. But one way is that we use our contact listener that we created in one of the previous parts, and there in the begin and end contact we are now implementing our logic. So the first thing that we need is that we want to get the entity information out of the contact. So we have an entity A, which is from our context from fixture A, the body and the user data. And this is actually an entity. And we would need to cast it. And isn't that super annoying and very long, because we need the second thing for our entity B. And do the same thing again. So why not improve on that and write again utility or an extension property in that case. So we have from a fixture, we get an entity which returns an entity. And there we implement the getter, which is simply from the fixture, the body, the user data, and return that as an entity. And then below here, we can simply write fixture A entity and fixture B entity. So that's already quite nice. Now what we want to do, we want to check if entity A is a tiled component entity and collision B and entity B is a collision component entity, or vice versa. And in such cases we want to update the nearby entities. So we have our when statement, and there we check entity A in tiled components and entity B in collision components. Then we want to update the nearby entities. So from the tiled components of entity A, we would add entity B, and the same we would do vice versa. So if entity B is in the tiled components and entity A is in the collision components, then we will do something like that. Okay, let's introduce those mappers. Maybe you might ask, why do I need to define the mappers for every system? Isn't that a little bit annoying? And I agree, so it would be great, like similar like Ashley does it, that this is just maybe a static reference to a component mapper. But again, this could have some problems on Android again and is not ideal. And also what I personally like about that approach, you immediately see if your system is doing too much. Because right now this one has already 4 component mapper, which I think is still okayish. So maybe that's the limit that the system should have access to. If your system needs, I don't know, 10 different components, and in the constructor you notice that quite easily what kind of dependencies your system has. And if this list here simply grows too much, then you should think about, is it really a good idea to have all of that in a single system, or should you start to split it up? So this is why I see that even nowadays as an advantage when you have to specify all of that, because you really need to think, and you will notice, wow, my constructor dependency list here gets quite long. Maybe I should refactor it a little bit and yeah, get something out of it. But again, for now, so those 4 mappers here, I think is still fine. So we will work with that. Oh, okay, and here we actually want the nearby entities. We did not write that properly. So it should look something like that. We have here a problem in this code, and I give you a hint. For our collision entities, we have just one fixture. But for our player and slime entities, we have multiple fixtures. We have the hitbox and we have the collision box. So in that case, a single entity could trigger that code 2 times. Maybe even in the same frame. And because we are using here a set, it might not be a problem. But just to be safe, we should implement it properly. So that's why we need to check for additional things. So the important part is here that entity A is in tiled components, and also it should be a sensor. And why should it be a sensor? Because currently it isn't a sensor. So when we go to our physics component, and physics component from shape 2D, then as you see, we just create this loop and that's it. So that is not a sensor. But what we actually want is when we have a collision entity. So for example, this rock here. Can I get rid of that? Yeah. So this rock here, what we now want that it checks if there are nearby entities. And the way I implemented that is that every collision object entity, so every box 2D body in that case, also gets a sensor around it. So a little circle with a specific size, and everything that enters that circle, so that sensor, gets added to the nearby entities list. And if something moves outside of that sensor, then it gets removed from the nearby entity list. And yeah, so that I added as a sensor to any collision object. So what we are currently missing is adding the sensor in here, and this is also simply a one-liner. So here we add a circle fixture. The radius is our spawn area size from our collision system. I think I made that private. Ah, yes. So it should be, of course, public. So it should be the spawn area size. And to avoid problems when something is exactly on the edge that it gets added and removed from the nearby entities list all the time, we simply increase that. And as a tolerance, for example, let's take a size of +2. And in addition, we say that this specific fixture is a sensor. I'll show you in a moment how that looks like then in our game. Okay, so then we have now this sensor, and coming back to our physics system, we can now check for that. So now here we want to check that contact fixture A is a sensor. And the same with our dynamic bodies. So there we really want to check that it is actually not the sensor. So it's the real collision fixture and not the hitbox or maybe any other thing that we add to our dynamic bodies. So there, in addition, we also add here that contact fixture B is not a sensor. And this is quite of a long condition and maybe also not that easy to read. So that's why we store that in separate variables, makes it then easier to understand and easier to read. So the first one would be is entity A tiled collision sensor? That is this first part. Is entity B collision fixture? And that is that second part. So when entity A is tiled collision sensor and entity B is a collision fixture, then we do that specific thing. And yeah, same here below. So here we simply copy and paste that again. Okay, so here we have an entity B is a tiled collision sensor and entity A is a collision fixture. Then from entity B, from the nearby entities, we add entity A. Okay, so this method is called when a collision is happening, so when a contact is starting. And there we add any additional entity that enters the sensor of this tiled collision object. And the second thing is the end contact method, and there we want to remove now something from the nearby entity. So let's, for example, just copy and paste the code here below. And here just replace that with a minus. And you might think that's already it. But you are terribly wrong. Unfortunately, because there's a special case when an entity gets removed, so really removed from the world itself, then, as I mentioned in one of the previous parts, the end contact method still gets called because the box2d body also gets removed at that moment, and that also then triggers the end contact method. But at the point in time when the entity gets removed, it does not have any components anymore. So we actually cannot check if it has a collision component, or yeah, in this case, if it has a collision component. So that's why we cannot apply this check in the end contact. Here really we need to do, so if entity A is a tiled collision sensor and the fixture B is simply not a sensor, then we just want to remove it. We cannot check here for the collision component because it's gone when an entity gets removed from the world. This is just some special case when it comes here to the entity component system, and there are always things like that. So there you need to be careful when using that, and depending on what kind of framework you are using, there are always some special things when it comes to those. And here the special thing is that an entity that gets removed does not have any components anymore. So here we can simply do that. So entity B is not a sensor, and here entity A is not a sensor, and then we are going to remove it from the nearby entities list. Okay, so this is one way how to react on collisions in box2d. So when a collision starts and the collision ends, then you can check for whatever things you want and execute some logic in there. So this is one of the ways that you can do it. There is another way that we learn in a part in the future when it comes to a tag system. But let's see if that one is now working, and that you also see what I meant with that sensor from a tiled component. So here you see it already. So we created some collision objects for the tree and for the stone, and then you see these big circles around all these collision objects. So this is the sensor, and when we move outside of these sensors, then yeah, you see that already below. So when there is no nearby entity anymore, so here, for example, the player is outside, then the collision objects here below also get removed. Those here on the right side, they will still remain because there's also the slime which is interested in collision handling, so that's why the collision objects still are created and remain there. But for other things like here, so player gets close, object gets created, player gets outside of the sensor, then the object gets removed. So that way we really dynamically create and remove such objects, and that helps then, especially when you would introduce very huge maps and big maps, that you don't have a lot of physics computation because you optimize the amount of bodies that get created. And yeah, seems like it's working quite well. Okay, so to summarize it once more, because I think that is also one of the more complex parts, but also an important part of Box2D. So what we do in our collision spawn system, what did we change here? We are now iterating over all entities which have a collision component, so entities which are interested in collision handling or collision stuff for our game logic. And for all such entities, we check in an area around them. So in the spawn area size that we defined, we iterate through all the cells of the tiled layer where they are currently in. So all the different tiled layers, we check, is there any tile, is the cell linked to a tile which contains any objects? And if yes, then we create those collision objects out of it. And we also highlight them in this, or mark them in a special way with this tiled component so that they have a reference to the cell, and they also keep a set of entities which are currently nearby of that collision object. Then we introduced a despawn system which goes over those tiled component entities, and it simply checks. So if there are no nearby entities anymore, then those entities get removed. And also they trigger a collision despawn event so that our processed cells, so that we don't create those collision objects again and again and again, so that they only get created once. And when something gets despawned, then we remove it from these processed cells so that the collision objects can get created again and again. Then we updated the physics component so that we add now this circle sensor to such tiled component entities, and this sensor is used to keep track of the nearby entities. So when something goes out of that circle, then the nearby entities get updated by removing such entities, and when something goes inside of that circle, then entities get added to that. And all of that is done with the contact listener of Box2D, and there we implemented some logic for the begin contact and end contact method. And for end contact, it's important to know that this also gets triggered when entities get removed from our entity world. And in such a case, we still have the reference to the entity because the user data of the body is still linked to the entity, but the entity itself does not have any components anymore. So they are already cleaned up at that time because the entity actually got removed from the world. So that's why we cannot check here for these collision components. Okay, so that was really one of the most complex parts that we are going to implement with this Box2D, but I think it's a very cool feature and also a very useful feature. So with that, we can really use the collision editor of tiled, and no matter what size we pick for our map, we don't overload it with useless Box2D bodies because they really get created and removed dynamically, and with that way we really keep the computation effort for the physics simulation to a minimum, I would say. So this is quite optimized then. Okay, then thanks for watching again, and see you then in the next part. Bye bye.